In this video, we're going to look at sample spaces, something called the multiplication principle, and some basic probability. So on this first type of problem, they are telling us when planning a cruise, you have a choice of 3 destinations. So we have Cozumel, Jamaica, or the Grand Caymans. Now I'm going to draw something called a tree diagram just to kind of help me organize the information. So I have to first choose my destination. So I either have Cozumel, Jamaica, or the Grand Caymans. Now, once I've chosen my destination, it says there are 4 types of rooms. So you either have a balcony, you have an inside view, you have an ocean view, or you have a suite. And so that would be for all of the destinations. They all have a choice of a balcony, an inside view, an ocean view, or a suite. So you'll notice each of those get 3 or 4 different choices off of the 3 that we started. And then finally, there are 2 types of excursions. So you have water sports or horseback riding. So you would have water sports or horseback riding, and that would be off of each of all of those, depending on which destination you chose, which type of room, and then of course, I'm not going to label all those, but you can see the point. So what the multiplication principle says, if you were looking at total number of outcomes, if you take the number of choices you have on the first stage, so we had 3 choices of destinations, times the number of choices you have on the second stage, so we had 4 different types of rooms, times the number of choices you have on the next stage, so we had 2 types of excursions, altogether that would tell you, so 3 times 4 is 12 times 2, how many total outcomes there are. Now, this particular problem, they didn't ask how many outcomes, they wanted us to list them, but it's a good idea to know how many, to know when you've listed them all. And if you draw this tree like this, it makes it a lot easier to know which ones you've listed versus what you haven't. So I'm just going to follow the tree. So there's going to be a lot to list because we've got 24. So we have the Cozumel with the balcony and the water. Or we have Cozumel with the balcony and the horseback riding. And then we have Cozumel with the inside view and the water, and then Cozumel with the inside view and the horseback. And then we have Cozumel with the outside view and the water, and then we have Cozumel with the outside view and the horseback riding. And then finally we have Cozumel with the suite and the water, or Cozumel with the suite and the horseback riding. So right there, we've got 8 of the 24 choices. So you're just going to keep doing that. Now we're going to work our way down where, if you chose to go to Jamaica. So we have JBW, JBH. And then we have JIW, JIH. And then we have JOW, JOH. And finally, JSW, JSH. So there's all the ones with Jamaica. And then finally, if we had chosen the Grand Caymans, we'd have GBW, GBH, GIW, GIH, GOW, GOH, and GSW, GSH. So that's what you're doing when you're listing them. Again, to me, I think it helps to draw the tree and also know how many you're trying to expect. Okay, on this second type of question, they are telling me I have a sample of 500 adults. They were surveyed on their health. It said 79 of those surveyed have high blood pressure, yet 96 of those studied reported being unwilling to change their diet. Based on this sample, if an adult is chosen at random, what is the probability that he or she is open to try to eat more healthfully? And we're going to express the answer as a fraction in lowest terms. Okay, So we are focused on who would be willing to eat more healthfully. So notice they told me 96 are not willing to change their diet. And so that was out of the 500 they surveyed. So if 96 are not willing, it must mean that the 500 minus the 96 are those that are willing. So we're going to first subtract that. And so we're left with 404 people that are willing to change their diet. And with probability, you take that number divided by a total that you're looking at, which is 500. And because they want the answer in lowest reduced form, notice both of these numbers you can divide by 4. So I end up with 101 divided by 125. And so you can either write your answer as the fraction, or it said if you're going to do a decimal, make sure you go to the nearest millionth. So tenths, hundredths, thousandths, so they don't have enough. Well, I guess because the decimals are zeros there. So just make sure if you're going to put it in decimal, I'd leave it in fraction, but if you're going to put it in decimal, make sure you go to the nearest, which would involve 6 decimal places, unless the decimal, like in this case, ends. Okay, so next example, find the probability of obtaining exactly 9 heads when flipping 10 coins. And it says express your answer as a fraction in lowest terms, or again a decimal, round it to the nearest millionth. The first thing I'm going to think about here would be the denominator. So if I am flipping 10 coins, then there are 2 possible outcomes on the first coin, times 2 possible outcomes on the second, the third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So that's what I would look at first. There are 1,024 different outcomes whenever you flip a coin, or you flip 10 different coins. So what we're looking at is what's the probability that we get exactly 9 heads. Now, when you think about that, that's the same as saying you get exactly 1 tail. And to me, that's easier to think about as opposed to exactly 9 heads. So what I think about is my 1 tail could be in the first position, so that's one way. Or the 1 tail could be in the second position, so that would be 2 ways. Or it could be in the third position, and so on. So in other words, there are 10 different places that your 1 tail could end up. And if you have 1 tail, then that means you have 9 heads somewhere else. So this would represent the probability of getting exactly 9 heads when flipping a coin 10 times. And then if we reduce it, these are both divisible by 2. So we end up with the fraction of 5 out of 512. And again, they said you could leave it as a fraction, or round it to the nearest millionth, which would be 6 different decimal places.